Okay, good morning class. So today we're looking at the sine, cos and area rule. We're looking at exercise, the answers to exercise 10.2. Exercise 10.2, the odd numbers, okay, or every alternate sign. Okay. So in question 10.2, or exercise 10.2, we are asked, in this exercise, write the answer correct to one decimal place where necessary. So they ask us to complete. They ask us to complete in triangle LMN. So what I do is I just draw a triangle in LMN. So what I see is small lowercase letters. So there is lowercase n, there's lowercase m, and lowercase l. So the area of triangle LMN is equal to half. If you got angle M, it's going to be half Ln sine M. Can you see that? That is now angle M. Or if we got, in the other case, we got half Lm. We got that and we got that. So it will be sine of angle. And why? Because the angle N is the included angle. You all agree with that? Any confusion? Confusion? No. Number 3. In number 3, they are asked to complete. So we have triangle HJK. So that is HJK. So that is lowercase k, of course, lowercase j and lowercase. Alright, so if you got sine, if you got sine of h, you got angle h, so it will be a half kj or jk sine of angle h. And same triangle, if you got angle k, it will be half jh, it's hj sine of angle k. Very simple, no? Let's look at the next one. Was that no, number 3? Yes. We look at number 5. Number 5, let's do 5a. So here we are asked to determine the area of the following triangle. What do we need for the area? We need two lengths and an included angle. Not so. So the area for this is going to be area is equal to half QP times QR sine of angle Q. So it's going to be half QP 5 QR 4 times sine of 30. Sine of 30 is half, so the answer is 5 centimeters. If you didn't know that, people, no problem. You could have found it in the calculator. Sorry about this now. Going to be 0.5 times 5 times 4 times sine 30. Gives you 5 centimeters. Alright, any confusion there, people? Let's go with C. Again, we have two lengths and included angle. But we say, hang on, this is a right angle triangle. So do I have to go with the sine, the area rule here? No. I could have just gone. Area is equal to half base times perpendicular. So you go half. What's my base? 5. What's my perpendicular? Yeah. So it's going to be 45 over 2. Or 22.5 centimeters. Okay, you all agree with that? People, otherwise, if you had used the sine rule, it would have been just the area is equal to half AB times AC sine of angle A, which would be an half times 9 times 5 times sine of 90. But we know sine of 90 is 1. That's why this would have also given you 22.5 centimeters. Can you see that, people? But we should have identified that, hang on, this is a 90 degree. So I didn't need the sine rule. But if you, not the sine rule, sorry, the area rule. But if you had used the area rule, you would have gotten the same answer. You guys understand? Okay. E. Do we have two lengths and an included angle? Yes. So, area is equal to half KL times LM sine of angle. Again, it's two lengths and an included angle. So it's half. KL is 3 times LM is 6 sine of 140. It's 0.5 times 3 times 6 times sine of 140. Gives you 5,79. 5,8 centimeters squared. They told us to use the 1 decimal place. Number 6. Number 6 is not even, but we said we're going to do every alternate sum. Okay, that is just an indication there for us. For next year we will do the even for the other sums. People, in each case, calculate the area of triangle ABC, correct 1 decimal place, given the following. So here no triangle is given. So what do? I draw. So we know it's going to be triangle ABC, not so. So it's going to be ABC. Angle C 65 degrees. Lowercase a, which is there, is 3. Lowercase b, if that's vertex b, lowercase b is opposite, it's going to give you 6. Do we have two lengths and an included angle? Yes. So we say area is equal to half AB sine C. So we go half. A is 3, B is 6, C is 65. Let's go, we put it in the calculator. 0.5 times 3 times 6 sine of 65. 8 comma 2. 8 comma 2 centimeters. You guys understand? See? Let's keep this question number in focus. Yeah, let's put it here. So again, we have triangle ABC. So ABC. Angle A is 39 degrees. Not so. Lowercase b, which is opposite vertex b, is going to be 8 centimeters. Opposite C is vertex C is C, which is 12. Do we have two lengths and an included angle? Yes. So we go, area is equal to half BC sine of angle A. It's going to be half. B is 8 times C is 12 times sine of 39. It's going to be half times 8 times 12 sine of 39. Is 30 comma? 2 centimeters. Any confusion there? Number 7. We also calculate the area of the following shapes. You have an isosceles triangle PQR with PQ equals PR. So in other words, PQ is also 6. Angle R is also 48. But what do we need for the area rule? 2 lengths and included angle. Can I work out angle P at this point? Yes. So angle P would simply be 180 minus 2 times 48, which gives you an answer. 96 is going to give you 84. Is that correct? Okay, one side. So we have 2 lengths and an included angle. You see that, people? Do I need to write it out? Do I need to say that angle R is 48? The reason angles are opposite equal sides. Do I have to give the reasoning? No. Why? We're not busy with Euclidean. If it was Euclidean geometry, I had to give that. Okay? Then PQ is also equal to 6y. So it's given. Again, we don't need that. And then the angle P is equal to 180 minus 2 times 48, which is 84. Sum of triangles being triangle PQR. Again, that is not needed. Okay. So let's go. So the area, how do you calculate area? It's half PQ times PR sine of angle P. Can I just say angle P or must I say QPR? Just say angle PY. There's no other angle at P. Okay, so it's going to be half PQ is 6 times PR is 6 sine of 84. So it's 0.5 times 6 times 6 sine of 84. You 17,9. So 17,9 centimeters. Any confusion there? See? And see, we are told the parallelogram is calculate the area of a parallelogram. But we know that the diagonal of a parallelogram divides the area into 2. Or bisect the area. Can you see that? So in other words, if I can calculate the area of triangle DAB, we can work out this triangle. The area of that, what would I do then? Multiply it by 2 to get the area of the parallelogram. You guys understand? So what do we still need in triangle ABD to calculate the area of this triangle? We need AD, but we know AD is 4 centimeters. Why? Sides? Opposite? No. Okay, firstly, we don't need the reason. But the proper reason here is 2 pairs of opposite sides equal in that is your reason. Okay, 2 pairs of opposite sides are equal in a parallelogram. that is 4. People, can I calculate the area now? So area of triangle ABD. I don't have to say this as well. Okay, what can you do? Area of triangle ABD, what would it be? It's half of AD times AB sine of angle A. It's going to be half. AD is 4 times AB, 5 sine of angle 120. So now gives us 0.5 times 4 times 5 times sine 120. You 503 centimeters squared. Yeah? So therefore the area of the parallelogram ABCD equal to 2 times 5 root 3, which indeed is 10 root 3, and in its decimal equivalent will be 17,32. So 17,3 centimeters.
Sir,
Yes?
could you also have used the formula for the parallelogram?
What is the area of a parallelogram?
B times the perpendicular height.
Yep. What? The base? Yes, the base times perpendicular height. But do you have the length of the perpendicular height here? No. We don't have the length of the perpendicular. That would have been your base here, which is 5. But we don't have the length of the perpendicular height, so you could have used it if it was given. Anyone else? Number 9. Number 7. There's the last one, huh? No, there's a 11. Okay, so triangle CAR has an area of 50 centimeters squared. So the area is equal to 50 centimeters squared. Calculate the length of RA. People, as you can see, we got that length. We want to calculate that length, and we have the included angle. So we straight into the sine rule. Not so. So let's go. The area of CAR is going to be of CR times RA sine of angle O. So it's going to give us half CR 18 times RA, which is what I'm going to calculate, times sine of 120. Okay. So what's the area? 50. So I'm going to get RA on its own. Divided by half 18 sine 120. Half 18 sine 124. That cancels. So therefore RA is equal to 0.5 times 18 sine 124. 6,7. Is that correct? 6,7 centimeters. Okay. And then of course the last one. This exercise. Determine the length correct to one decimal place of the side of an equilateral triangle. People, if you've got the equilateral triangle, what is significant about the equilateral triangle? All sides are equal. We'll make that x. Not so. And all the angles are equal, which is 60. Of an equilateral triangle with an area. The area of this is 24 centimeters. So you must calculate the length. Okay. So you all agree that That length is the same as that length. Why could have gone any other way? And we got an included angle there. Not so. That's the area. So there's no length and whatever on here, so I go straight, do the substitution. So area is equal to half AB sine C. Okay, as you can see, there's no letters there. So we then go, what's the area? 24 is equal to half. What is A? X. B? X. Sine of? To get X squared on its own, I'm going to divide by half sine 60 both sides. Okay, so X squared is equal to, as X times X is X squared, 24 over 0.5 sine 60. Is that 32 root 3? And then the square root thereof. We would normally go plus minus, but not in this case, because we are referring to length, and length is negative 7 comma 4. Is that correct?
Yes.
7 comma 4. Since that is in centimeters square, must be centimeters. Okay. Any confusion here? Alright, so that basically brings us to the end of exercise 10.2. Okay, so you didn't do your homework, Michael? The full lesson can be found in the description box below.